Hey everybody. Okay, here we are on the last video. This one's going to be really similar to the one before, so that's cool. But notwithstanding the repetition, I think it'll be good to have another one like this in conjunction with the examples of the book. All right, so the chart shows the relationship between the number of clicks on a scope and its effect on the drop in a bullet. Okay, the circular adjustment knob on a scope is designed to click to a positive stop at equal intervals as it rotates so the shooter can know how far the knob has rotated. All right, so use regression and the graph of the data to find the best model for the data considering blah, 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 blah. Okay, so check it out. I mean, this time we've got 1, 2, 3 columns of data. Well, we only need two of them. Which two? Well, it says do regression and a graph to find the best model for the data considering the number of clicks as a function of the drop. So clicks is going to be the function. Function is f of x. F of x is y. So clicks is our y value. And therefore drop will be our x. And so we're not even going to need to use that first column of information to answer the questions, although it is interesting to have it there. Okay, so that's very important. Being able to read this correctly to know which information to grab. Okay, so let's go to the calculator. So I quickly put all the data into the calculator. Wow, that was fast. And now I start. Now I need to start looking at those. Well, I guess before I start looking at the R squared values, I'm going to just take a look at this thing. All right. So, oh, I've got some old stuff here I don't need. Okay, so I'm going to go zoom 9. And I'm looking at that and I'm thinking, all right, what kind of model does this look like? I mean, it's fairly straight line, but obviously there's some curve there. So I doubt linear is going to be our guy. Okay. So, but I mean, I could see any of them working. Usually, though, I mean, probably not logarithmic, because logarithmic, yeah, it comes up and it goes over, but usually it starts off really steep for a little bit, and then it starts flattening out. This just kind of starts flattening out immediately. So I doubt logarithmic is going to be the way to go. Anyway, so let's figure out what we got here. Hopefully, you are not hearing my children too much. I had to wait till they were done vacuuming. Let's see what comes next. Exponential. It doesn't order logarithmic. Okay, let's take a look at those wonderful R values. And so I'm going to go stat over 4 for linear. Oh, well, wait. I was going to show you something else. I don't think I showed you in this last video. I'm just going to store all the equations so I can see the graphs. I'm going to go alpha, green, trace, and then I'm just going to say y1. And then when I hit calculate, yeah, I get the function, and yeah, I get the R squared value, 0.9773. Okay, but by doing that alpha trace trick, it pops up in y1. So there's the function, all typed in without rounding it off. So isn't that special? Yes, that's wonderful. Let's go do quadratic. And I'm going to store that in y2. So alpha trace, move the down arrow to get y2. Okay. And what have we got here? 0.9967. Ooh, okay. So not only did quadratic look better on the graph than linear, well, no surprise, it gives us a better R squared value. Okay. I got something on my teeth. Okay. I had this really good homemade bishop bread my wife made. It has like nuts and chocolate chip and no, not grape, raisins. My wife made some raisins from our grapes in the backyard. Yeah, I'm really spoiled. Okay, so now we're going to go to power model. This is where things start getting interesting. Okay, and I say, yeah, let's put that in Y3 because I want to see all of them together. You don't have to do it that way, but I want to. And besides, this way you learn something else. And uh-oh, Spaghetti-o. All right, so value entered is not allowed in the function or command. Huh. Okay. So here's the deal. As you have undoubtedly already seen, going through chapters 3, 4, and 5, um, some of these functions, they don't like having 0 for the x value. They just don't work. Like the logarithmic is not going to work if you have a 0 for an x value. Exponential is not going to work if you have 0 for a y value. And power function is not going to work if you have either of them. So something you can do, and you have to be very careful, is we can delete the 1 point just so we can get some information. So I'm going to delete just that 1 point, 0, 0. Okay. And I have to kind of do that with a grain of salt, knowing that, well, okay, so now I've lost just a little bit of data. But it's still going to basically be the same thing. I mean, if I look at the graph, I mean, yeah, all the points are still there except for the one right there. But the pattern is still still there. Okay, so let's try that again. So I'll go over here to power model, and I'll put it in Y3. Yeah, I think you can hear my kids, those goobers. All right. Let's see, power 0.9994. That is our strongest one yet. Okay, not much more than quadratic, but it is more. Okay. All right, let's try the next one. Stat over exponential. I'll put that in Y4 because I want to, not really much other reason. Okay, so we're going to go 0.7435. Whoops. 74. Okay, now that is clearly our worst R-squared value. I'm very comfortable right now saying, that's not going to cut the mustard. Okay. Oh well, that's normal. At least one of them usually doesn't do well. Now let's do logarithmic, and I'll stick that in whatever it's called, Y5. And okay, and that R squared value is certainly better than the exponential, but it's certainly worse than the first three. Heck, even linear is better. Okay, and now out of morbid curiosity, let's just kind of see how things look. And remember, it's gonna graph them in the order in which they appear here on the list. Okay, so there's linear, quadratic, power, exponential, and logarithmic. Okay, yeah, this exponential, you can see why it's not a good fit. It doesn't even follow the pattern at all. Linear kind of follows the pattern, logarithmic kind of follows the pattern. I tell you what color I'm looking at, but I'm colorblind. It's either green or orange or red or brown. So I know that wasn't very helpful. Anyway, it definitely doesn't follow the pattern as well. Now, I could just say, all right, well, I know that it's not logarithmic, so I'm going to hit enter right there, and that'll turn off that function. I know it's not exponential. I'm going to hit enter on the equal sign, so turn that off. I know it's not linear, so I'll turn that one off. And now I can just kind of compare quadratic and power. So there's quadratic, and there's power. And yeah, I mean, right around the points, they're about dead on each other. So we're going to go with power, partly because power model has the best R squared. Hang on, I want a new color. Power model has the best R squared value, closest to 1, but also remember the quadratic model. That's the one in red, I believe. It's going to go up, and then it's going to come back down, which doesn't make any sense, okay? Because having it come back down means that, if your drop goes up high enough, Okay, so you just keep getting higher and higher drop, higher and higher drops, corresponding to further and further shots, like 600-yard shots, 800-yard shots. Eventually, if your drop goes high enough, then the number of clicks that you do starts dropping. And then and that doesn't really make sense. Okay. And so because that doesn't pass the common sense test, that's another reason why I want to go with power. So power model, that's my guy. So I'm going to go back and go get that power model. This time I'm actually going to write it down because, kind of need it. So let's see, it was, I don't think it said how many decimal places. I'm going to pretend it said 2. Okay, so 7.34 x to the 0.73. Okay, so I've got that fun stuff there. And now most of the interesting stuff is done, or all the new stuff. Briefly defend the equation you chose to model the data. That's all I've been doing. Part B, or C, use your equation to determine the number of clicks. So clicks was y. Determine y if x is 48 inches of drop. Okay, I can do that. So I'm going to go 7.34, and heck, I already forgot. 48. Okay, 48. Okay, so x is 48 inches of drop, and there we got that. So our answer to C is 123.8, 123.9, 124 clicks. All right. Now, does that seem reasonable? You always want to say, does that just make sense? Well, 48 inches of drop, that's right in here. So we would expect the number of clicks to be somewhere between 112 and 134. Okay, which we got about 124. Cool. Part D, use your equation to predict the drop for 250 clicks. So this time we're going to go, they're giving us the y value of 250, which is bigger than any of the other y values, and therefore I expect the drop to be bigger than 103.7. I don't know, maybe 110, 120. I'm not real sure. And that's okay because, we can still be friends. So 250 for the y value. All righty. So I'm going to plug in 250. Wait. Hang on. Check this out. Give myself a little extra. No, I'll just do it then. Okay, so 250 for y is 7.34. I know that I'm getting a seizure just looking at the cursor, but that's kind of fun. So I'm going to divide by 7.34, just like we learned in chapter 3. And let's see, where's the cursor? Or thingamajig. Okay, so we're going to go 250 divided by 7.34. Okay, we get 34.06. All right, I got to get rid of some of this stuff. Okay, 34.06. Equals this and that and that. Okay, cool. All right, now what do? Well, we raise both sides to the 1 over whatever the power is, 0.73. 0.73. Okay, so those guys cancel, which is the whole point, and we just end up with x equals something. I don't know. Let's see. So we got to go. Let me grab my 34. Go up here. Grab that 34.06 number. I'm going to raise it. I'm going to raise you $5 to the 1 over 0.73. And again, I can get better information if I don't round off that 7.34 and the 0.73. Okay, but it should be okay. And I get 125.6 clicks. So depending on, what you prefer as a shooter, you might round down to 125, you might round up to 126. So, me, I am not an expert, but yeah, so that would be it. 125.6 clicks or something like that. And that's it. Okay. It's been real, it's been fun, and it's been real fun. See you later. Bye-bye.